model roller coaster trying to get this marble through both loops. But it keeps running out of energy before it gets through the first loop.
It seems like the marble doesn't have enough momentum to carry it through the coaster.
I'm sure we'll find a solution in no time. Every day we're surrounded by examples of forces in motion.
Forces can cause an object to move, like the pull of a paddle propelling a kayak through the water.
Forces can cause an object to slow down, like air pushing against a parachute as a skydiver lands.
Forces can cause an object to change direction, like a soccer player's foot intercepting a pass and sending it back down the field.
Hey, I think I'm beginning to understand the problem with our roller coaster. The marble needs more energy to get through the loop. I just need to figure out what changes need to be made.
Right. We need to increase the force causing the marble to move forward. We also need to consider friction, which might cause the marble to slow down.
What do you think we could try or investigate to make this model roller coaster work? See if you can come up with some answers. We thought of a few experiments that might tell us what changes could be helpful. I hope you thought of some ideas too.
Okay, let's think about how to set up the experiment.
One of the experiments will test whether the height of the hills will change how far the marble will travel. I'm going to use a ramp and a toy car.
Since we're testing the effect of the height, let's keep everything else the same, so we'll be able to see the change we observe in the distance.
Here's a data table showing 4 different ramp heights, with 2 trials at each height to increase our accuracy.
We can measure the distance traveled with this meter stick and see what our data tells us. And we can use these books to change the height of the ramp. Here we go.
So how many centimeters was it?
41 centimeters.
Let's try it again for accuracy.
Looks accurate, 40 centimeters. Now let's add a book to increase our height. "64 centimeters.
Here are the rest of the results from our experiment. I already know that gravity pulls the car down the ramp, and from our results, it looks like the taller ramp makes the car travel further.
I think this might be helpful for our marble roller coaster.
Another experiment we could try is seeing if we start the car at different points, if that will make a difference. We could use the ramp to test this experiment.
Great idea. We'll need to use the meter stick to mark some different distances on the ramp, and to measure the distance the toy car travels each time. The ramp can stay at a constant height, and we can change the starting point of the car to see what effect that has on the distance. Let's try it.
Here are the results. It seems like when the car starts further up the ramp, the object travels farther.
So in our marble roller coaster, let's try moving the starting line backwards to see if that will help the marble make it through the first loop.
There are so many things we can try. I could do an experiment to test the effects of friction on the car's motion.
We could also test whether a greater force applied at the launch would increase the distance traveled.
I think I'll start by changing the height of the first hill and see if that helps. I can always do other experiments later.
There are so many ways that forces can affect motion. Maybe you can come up with your own experiments.
For now, wish us luck. See you next time.